Hi everyone, welcome to Key Skill 4 in the Binomial Expansion series. Today we're going to be looking at what we can do if the question asks for a specific term in our expansion. So in the previous key skill, we looked at how we can generate all of the terms, or for example, the first 3 or 4 terms in expansion. But what if the question asks you specifically for the third term? Or what if the question asks you specifically, what is the coefficient of x6? Is it really necessary to do out the full expansion, including all of these terms here, that you don't need? Well, the answer is no. And how we get around that is by using the general term of a binomial expansion. The general term is a formula that we can use to find a specific term. So only one of the terms in the binomial expansion. So maybe the question would say, what's the second term? Or what's the term independent of x? In those situations where the question's asking about one term only, not the full expansion or multiple expansions, not find the first 4 or 5 terms, no, they're asking for one term only, I personally would always use the general term. Now, to use the general term in the expansion, you need to know what n is, so that's our power, and you need to know the formula for the general term. So t is for term, so tr plus 1, I'll explain r in a second, is equal to n choose r times by a to the r times by b to the m minus r. So we've already talked about what is n. N is the power, so here and here, I would be filling in 6. A and B, you can switch around to B, for example. This one can be A, and this one can be B, or vice versa. It doesn't matter. As long as you have one of them with a power R, and one of them with a power n minus R. So far in our formula, we've accounted T is the term number. So in the previous example, here we would be doing T would be 1, T would be 2, T would be 3, T would be 4. This is the first term, the second term, the third term, and the fourth term. So the term number counts which number we are in the expansion. And R in this case will change in each line. We always start on R is equal to 0, then we go to 1 and 2, and we keep counting R, increasing by 1 each time until we get to n. So if we're looking at this example here, we would have n is equal to 4, 3x squared is a, and minus 2 is b. This one would be t1, and r would be 0. This one would be t2, the second term, and r would be 1. This would be the third term, so t3, r would be 2, t4, and t5. Here r is 3, and here r is 4. Those of you that are very observant may have noticed one thing, and that's this. The term number is always one more than r. That's because in the first term, so when t is 1, T1, we set r equals to 0. So let's find the general formula for this example. Like previously, I'm going to start by writing down my formula. I'm going to leave the r as an unknown. That's going to be different, we'll see in the next examples, depending on what the question's asking for. So your general term is going to be left in terms of r. There's still going to be r's in your answers. So that's going to be 6, because 6 is the power. Choose r. A I'm going to have is 3. And b I'm going to have as minus 5x. Now, depending on which way around, you can either have this is r and this is m minus r, or the other way around. It actually doesn't make any difference. I think I'm going to have mine this way around, because I generally speaking like to start this power on 0. So I like to increase this power and decrease the power on the 3. but it's going to work perfectly well either way around. Now we have a formula for a general term in the expansion, and I'll show you how the question will go. Once you've got that, you can keep it safe. Now the question here is asked us, hence find the fifth term in the expansion. Most people go back to the previous structure I showed you in the last case skill, and they will do all of them, starting at 0, first term, second term, third term, fourth term, and they're going to keep going until they get to the term they need. This wastes a lot of time in the exam. You want to use your general term in the binomial expansion and go directly to the one you want. So let's copy and paste this in. Now, all you have to do in these questions is think, what should R be? In this question, we want the fifth term, so I want this to be 5. So I want T5. T5 would be the fifth term. So in this case, to get 5, R needs to be 4. So I would have 6 choose 4. Oh, I forgot to fill in my N here. This little guy's gone unnoticed. Let's fill him in. N is 6. And everywhere that I previously had an R, I'm going to replace it with a 4. So I'll put them in red. And after that, all you need to do is work out your coefficients. So the fifth term is going to be 6 choose 4 times by, I can work it out, so it'll be 15 times by 6 minus 4 would be 3 squared, so 3 power 2, which is 9. And we'd need minus 5 power 4, in case you don't know. Remember what I showed you yesterday, always have your minus numbers inside of brackets. That's an even number because 4 is an even power. So times 625, and that would be x power 4. Remember, like I told you yesterday, the 4 needs to power both the minus 5 and the x. They're both inside that bracket. And the fifth term, the final answer for the fifth term is going to be 15 times 9 times 625. Oh, it's going to be a really big number. 84,375 x power 4. So I hope you see the power of the general term. Instead of having to go through the first, second, third, fourth, and fifth terms, you can go directly to the fifth term. Now it's also useful here. Find the coefficient of x power 6 in the expansion. In this question, we haven't been told which number the term is, but we've been told the power of x. So like previously, we're going to start by working out the general term. I'm going to write the formula down. TR plus 1, n choose r, a power r, b power m minus r. So we're going to fill this guy in. And in this case is 8. So 8 choose r times by 2x squared power r times by minus a quarter power 8 minus r. So I've had this as my a and this as my b. Don't forget, you need to take the minus as well. Now, in this situation here, I need to again think, which value of r do I need? I need x to be x power 6, okay? So I'm going to tidy this up slightly. What I like to do is put all the coefficients, all the numbers, for example, here at the front. So I would have here 2 power r times by minus a quarter, 8 minus r. And at the back, I would have x to the power of 2r, because here I've multiplied these numbers. Remember, if you have a bracket, your rules for indices state you need to multiply. So if you think about that one was like a 1, so you've multiplied here the 1 and the r to be 1r, and here you've multiplied the 2 and the r to be 2r. So I need here x to be power 6. Well, I just need to look over here. What value of r would give me an answer x power 6? Or you can think about it like this. You can set up a little equation. X to 2r equals x power 6. So that must mean that 2r is equal to 6 and r is equal to 3. So once you know r, it's really easy. You just go back and sub it in everywhere. So we now know that r is 3. So we know that it must be the fourth term. I'm going to plug all of this in the calculator in one go to try and save some time. So 8 choose 3 times by 2 power 3 times by bracket minus a quarter, power 8 minus 3 is 5. Plug that all in, and I get the answer. The fourth term would have been minus 7 over 16 x power 6. So my coefficient would be minus 7 over 16. Okay, in question 4 it's very similar, but sometimes the wording throws people. The question says, find the term independent of x. So you're basically looking for a number without an x. So let's see if we can find one from a previous example. So for example, in this expansion here, the term independent of x would be 16 because it doesn't have an x with a power. Every other part of the expansion has got x power something. So this one here, the 16, is independent of x. The same here, if we were looking at this one, 1 is the term independent of x because everything else in the expansion has x, one of the powers of x. So I want you to think about this in your head like x power 0. That's the easiest way to think about it. You set up your general term, just like before, and choose r. A I'm going to put as 5x squared, so that's going to be power r. And this one I'm going to put as minus x power minus 1. I think it's easier if you've got an x on the bottom to remember your rules for indices and have your x as a minus power, right? So think about that as 1 over x power 1, bring it up. And that would be m minus r. I'm actually going to go ahead as well and fill in n is 9 here. Again, I'm going to regroup this so I have all my numbers at my front and my x's at the back. So the 5 to the r is going to go at the front, and then we're going to have x to the 2r times by, I'm going to split this up to think about this minus to be like a minus 1, okay? So I'm going to have that as minus 1 to the power of 9 minus r, and at the back I'm going to have x to the 2r, and if I multiply these together I would get x to the minus 1 times 9 be minus 9 plus r. This is my top tip, put these two together. You can add these because you're multiplying. 2r plus r is 3r, so you're going to have 3r minus 9. Now we need this one to be independent of x, so we need this to be 0. So solve that equation. 3r minus 9 needs to be 0, so r needs to be 3. All you need to do then is sub this 3 in everywhere. So r plus 1 would be 4, so it would happen on the fourth term. So we would have 9 choose 3, 5 power 3, minus 1 would be to the power of 6. And then it would be x, 3 times 3 is 9, minus 9, which is x power 0. Type this all into the calculator to get your coefficient. You don't need to type this in because this is just going to be plus 1, it's an even power. But if you weren't sure about that, you could type it in, as long as you use my golden rule and use the brackets. So that would give us, the fourth term would be 10,500, and x power 0 would be 1. So there would be no, you could write x power 0, but generally speaking, you just leave that as a number. And we are done. That's key skill 4 finished. I'll see you in the next one, guys. Don't go anywhere.